This video is going to be the first covering P5, factoring polynomials, and we're going to be talking about factoring using greatest common factors and factoring by grouping. The idea behind factoring is to reduce a polynomial to a form that is more manageable. In this first polynomial, this is a bit longer and maybe a bit harder for us to read, and also isn't as easy for us to get information about, which we'll learn about later. The first polynomial we can rewrite in the second form, which we would think of as our factored form. Now, factoring is rewriting the polynomial as a product of prime or irreducible polynomials of lesser degree. So notice that when we factored this polynomial up here, this first term in the product is degree 1. Same as the second, same as the third. They're all of degree 1. So if you can rewrite a polynomial as a product of degree 1 terms, then you're done. First type of factoring we want to talk about is greatest common factor. We're going to abbreviate that as GCF. Keep in mind the distributive property that we've already talked about. If I have two numbers, a times b plus a times c, I can factor out that a and have a multiplied times b plus c. That's what we're always going to be trying to do when we're talking about greatest common factors. An easy way to see this is, for instance, if you look at 6 plus 8, I can rewrite this as 3 times 2 plus 4 times 2, and I can then factor a 2 off of each term, right? So we don't necessarily have to factor out numbers. They could be polynomials, they could be variables, they could be monomials. Just depends on what we're looking at. Let's look at these two basic examples first. So we have 3x plus 3, and we want to factor this using a GCF. So we want to look for terms that we can pull out or that we can factor out that divide every term inside the expression. So here we see that each term, 3x and 3, has a 3 in it, so we can factor out that 3, and what I'm left with is 3 times x plus 1. How about 4x squared plus 8x? Well, each term has a 4 in it, also has an x in it. Now, notice the 4 because I can rewrite 8 as 4 times 2. So I can definitely take a 4 out. Let's start there. If I take a 4 out, I'm left with x squared plus 2x. Now, we're not quite done yet because we can do a little better. Still, we can factor an x off of each of these terms, leaving us with 4x times x plus 2. Now, you don't need to go through the step of factoring off each term individually. Once you notice that 4x is your GCF, you can go ahead and factor that off all in one step to get to this line. Some more examples. If we look at 6y to the fourth minus 18y cubed plus 12y squared, I think it's pretty clear that every term has a y squared in it. So I can definitely factor out a y squared. And what I'll do is, as I decide what I'm factoring out, I'll write that outside the parentheses. And then when I'm done figuring out what the GCF is, I'll figure out what I have left inside the parentheses. This first term has a 6. Now 18, I can write that as 6 times 3. So again, I have a 6 there. I might be looking for 6's here, and sure enough, 12 is 6 times 2. So that is going to be the second part of my GCF, is the 6. Now when I factor 6y squared off of 6y to the fourth, I'm left with y squared. When I factor 6y squared off of negative 18y cubed, I'm left with, well, I factored a 6 out, so I have a 3 left, and I'm left with 1y. Similarly, I'm left with 2 at the end because I factored out that y squared. Now, we always want to be asking ourselves as I'm factoring, can I factor any further? Well, this is a monomial, so that's good. If we have one of our terms in the product as a monomial, we're going to leave that one alone. This polynomial here inside the parentheses is of degree 2, so we would want to ask ourselves, can I factor that further? I'm actually thinking we can, but at this point we're going to leave it alone. We'll get to factoring this form in the next video. With this example, let's see if we can get our GCF first. So looking at the first term, I have square root 3. Oh, I have square root 3 in every term. So definitely in my GCF, I'm going to be factoring off a square root 3. Let's look at the p's. First term, I have a p squared. Second, I have just a p. Third, I have a p cubed. So the best I'm going to be able to do in terms of the p's is just take one p out, because again, this needs to divide every term inside this expression. As far as the f's go, I have 4 here, 5 here, and 3 here. So I'll take the least. I'll do f cubed, and then decide what I have left. Well, when I factored this term off of this one, square root 3, p, well, I took 1 out, so I have 1 left. When I took 3 f's out, I have 1 f left. Moving to the next one. Well, I factored the square root 3 out, so I have a 2. Took the p out, so I'm not going to have anything there. And I took 3 of the f's out, so I'm going to have f squared. And the third term, took the square root 3 out, so I'm going to be left with 1/4. Took 1 p out, now p squared. And I took all the f's, so that is what it's going to look like when I'm done factoring using GCF. Now, factoring by grouping. Whenever you start factoring or you have a polynomial and you want to ask yourself how to factor this, always start with GCFs. Now, with this polynomial, the GCF, the best we can do is a 1, and factoring out a 1 doesn't help us at all. So we want to start thinking about factoring by grouping. Now, what that means is you want to look at pairing up terms. So I'm going to pair these two terms together and these two terms together, and I'm going to factor by grouping on each of them. So for the first two terms, I can factor an x squared out. What I'm left with is x minus 2. Second two terms, I can factor a 5 out, leaving me with x minus 2. Now, once I've done this factoring by grouping, notice that what I've done is I've actually gotten a common term between these two. So I can factor out the x minus 2 in front. And again, this would be a GCF, because I have a greatest common factor of x minus 2 for each of these two terms. When I factor that out, what I'm left with is x squared plus 5. So another example. Factor by grouping. I'm going to group them this way. So I'm going to group x cubed minus x squared and minus 5x plus 5. From the first grouping, I'm going to factor out an x squared, leaving me with x minus 1. Now I can definitely factor a 5 out of these two, so let's do that. When I do that, if I factor a 5 out, I'm going to have minus x plus 1. One of the goals we want in factoring by grouping is we want to rewrite the polynomial so that there is a common factor. Notice though that x minus 1 and minus x plus 1, well, they're not quite common yet. So what we're going to do is look at the second one, the second term, and if I factor a negative 1 out of here, I can actually achieve what I'm looking for, because I'm trying to rewrite this as x minus 1. When I factor that negative out, I change the sign of each of these, leaving me with x minus 1. Now I have this common term, or this greatest common factor, that I can factor out. I have x minus 1, and what I'm left with is x squared minus 5. So let's pull both of these top two types together. Let's do greatest common factoring and factoring by grouping. So we have four terms here. We want to ask ourselves, is there a common factor? Well, I think it's pretty clear that a squared is a common factor for everything. Now, that's actually as good as we can do as far as a common factor for all these. So when I factor out a squared, I'm left with x cubed plus 2x squared plus x plus 2. Okay. Now, inside this, I want to try factoring by grouping. So I'm going to group here and here. First grouping, I can factor out an x squared. So I have x squared times x plus 2 plus, well, there's nothing I can factor out of these two, but what I'm going to do is I'm going to group them together with parentheses. And remember, this is 1 times x plus 2. Now, notice what I've done is I've rewritten this so that now I have a greatest common factor inside the parentheses of this x plus 2. So I want to factor that out, x plus 2 times, now when I factor that off of the first one, I'm left with x squared. And when I factor it off the second one, I'm still left with plus 1, okay? And just to write this how you're going to see it typically, it's going to be a squared times x plus 2 times x squared plus 1.